So now we're going to try to solve some maths. I have some sample questions over here. So let's begin with the first one. What are the electron and electric current in a 2 mm diameter copper wire if the electron drift speed is 10 mm per second? The electron density for copper is atto. So we have to find out the electric current, which is I, and electron current, which is small I, both respectively being I times E, I being I small I times E, where I is number of electrons per cubic meter times charge of an electron times the area area of cross section times the drift velocity, and I being everything similar to this without this E, which is NE times A times drift velocity. So basically we can find out I and then divide I by the charge of an electron to get the electron current. So here we are given the diameter, so we can convert this diameter into radius or use it directly as it is to find the area of cross section. And I will not be doing the maths, I will be just showing the steps. You guys can solve it, I'm assuming that. So let's calculate the area. So we know area is equals to pi r square, and r is equals to diameter by 2. So we can write that area is equals to pi times diameter by 2 whole square is equals to pi times diameter square by 4. So you can use this to find the diameter. So we are also given the drift speed or drift velocity, which is 10 millimeter per second. Just convert it into meter per second. Then we're also given the electron density for copper, which is the value of Ne, which is 8.5 into 10 to the power 28 per meter cube. And we know that the charge of an electron is minus 1.6 into 10 to the power minus 19 coulomb. So we can just plug these values into this formula. I is equal to this Ne times this E times the area of cross section of the wire, which is this A times this drift velocity, which we will convert into meter per second. So this will give us the electric current, and if we divide this I by E, we'll get electron current, which is this divided by the charge of an electron, this. So the unit of this will be ampere, and this will be ampere per coulomb. So this was a pretty easy question. Now if we move on to the second question, it says a silver wire of 2.6 millimeter diameter transfers a charge of 420 coulomb in 80 minutes. Silver contains this amount of 50 electrons per cubic meter. So this is the value of our Ne. So we have to find out what is the current in the wire, what is the magnitude of drift velocity of the electrons in the wire. So let me clear this out, or I can just make a copy of this question. bring it down here. Alright, so the question asks for the current in the wire in A, and in B it asks for the drift velocity. So to begin with, we know that I is equals to number of electrons per cubic meter times the charge of electron times the area of cross section times the drift velocity, right? So in here we are given only the diameter, which we can use to find the area. So let's put a tick over here. They also gave us the value of this, which is the number of free electrons per cubic meter. We know this, but we don't know the drift velocity. So here we can see that it is mentioned that 420 coulomb charge is transferred in 80 minutes, right? So we have to use this information and find the current. And secondly, it asks for the magnitude of drift velocity, which we can find out if we find the value of I. Sorry, I have to pick up a call. Alright, so we also know that this is equals to delta Q by delta T, right? So we can establish a relationship between these two equations. So in A, where it asks for the current, we can write that I is equals to delta Q by delta T, delta Q being 420 coulomb and delta T being 80 minutes. You just have to convert this minutes into seconds. So we know that 1 minute is around 60 seconds, so we can write 80 times 60, which is 4800 seconds, and this will result in something ampere. So this is the current. This is a solution of A, and now number B asks for the magnitude of drift velocity of the electrons in the wire. So we know if we have I, we can find this value simply by shifting this product into this side. So we can write that I equals to NE times E times area of cross section times the drift velocity. We can find the drift velocity like I divided by this times A, all of this which we can find from this question. We can find the area from this. NE is given over here, and we know the charge of electron is minus 1.6 into 10 to the power minus 19 coulomb. So moving on to the next question, we have a theory heavy question over here. It says these four wires are made of the same material. So same material means that the resistivity will be same for all cases. For all four of these cases, the resistivity will be same. We have to rank in order from largest to smallest the electric currents IA to ID. So we know that the electric current depends on two things. If we write the formula of electric current, we can see that I equals to NE times E times A times the drift velocity. So this part will be same for all four cases, as it mentions that these are the same metal. Same metal means that the number of free electrons for every case will be same. So we can just take it out of the equation. We can write I is proportional to the area, and I is also proportional to the drift velocity. The area is also proportional to the radius. So we can ultimately write that I is proportional to the given radius. So we can take equations or use the proportionality condition to solve this question. So I'll be using these equations and solving this. So I'll be not using this entirely, but you guys can use this also. So let us substitute N times E with a certain value, let's say K. So we can write I equals to K times A, my bad, K times A times VD, right? Let me clear this out. So for A, let's consider this as IA. We'll get K times the area will be pi r squared times V. For IB, the area will be K times pi r squared times 2V, or we can write it as 2 times K times pi r squared times V. Or we can replace this entire value by IA. So we can write IB is twice of IA. Similarly, for case C, if we consider IC, we can write K times pi 2r squared, which will ultimately give us 4r squared times V, which we can ultimately write as, if we bring this 4 out, we can write as 4 times K times pi r square, which is eventually IA. Right? And for the last case, which is ID, we can write K times the area, which is pi, R is 1 by 2 R squared times 2V, which gives us K times 1 by 4 R squared times 2V. If we cancel this out, we'll get half K times R squared times V, which is equivalent of half IA. I forgot the pi, which is half of IA. So if we rank them, if we rank them, we can write that the greatest is IC, then comes IB, then comes IA, and lastly ID. Excuse me. Now, if we move on to the next question, it states that a 10 ampere current passes through a 1 millimeter diameter copper wire. What are the current density and drift speed of the electrons in the wire? The electron density for copper is 8.5. Alright, so it asked for the current density, which is J, right? We know J is equal to I by A. They gave us the value of I, which is 1 ampere. They also gave us the value of diameter of the copper wire, so we can use it to find out the area. So we can just plug it in and find the value, area being pi d square by 4. I'm not gonna do this, you guys can do this by yourselves. And for the drift speed, we can find it by using this property, that electron density, which is Ne, is 8.5 times 10 to the power 28. We know I is equals to Ne times E times A times Vd. So we have this, which is this. We know the value of the charge of an electron. We will find the area from this, from the given diameter, and we can just find this, which will be Vd equals to I by Ne times E times A. It's that simple. Let's move on to the next question. It states that the current density of a cylindrical wire of radius 2 mm is uniform across a cross section of the wire and is J equals to 2 into 10 to the power 5 ampere per meter square. What is the current through the outer portion of the wire between the radial distances R2, R by 2 and R? So if we draw the wire, let's suppose this is the wire. Let us consider this as R. So hypothetically this will be R by 2. So this will be the area of cross section formed by R by 2, and this one, the whole, is formed by R. So we have to find the amount of current that is only passing through this area, this shaded area, this area is the area, like this portion, which we will get if we subtract the area of R and R by 2. If we subtract the area we get from R and the area we get from R by 2. But if you do it like this, we will not get the correct answer. We have to take the help of integration. So we know that I is equal to integration of J dot A. So as this is in the same direction, we do not need to write cos theta. We can just directly write I equals to j dA, as dot product gives us scalar quantities. As j is constant, we can bring out j and integrate dA. We know A equals to pi r square, so dA is equals to ddr of pi r squared, which will give us 2 pi r. So we can just substitute this with this, and now we can place the limits over here. So we can write j times 2 pi integration of r so integration of r will give us 1 by 2 r squared. We can just cancel this out. We can write it as j times pi times r squared. We have to put the limit, not limit, the bounds, and we'll get j times pi times r squared minus j times pi times r by 2 squared. You guys can find the answer out. You have the value of j, you have the value of r. You can get r by 2 by just by dividing this r by 2, and you know what the value of pi is. So this will be the answer. Sorry. Now if we take a look at the next question, it says the wires are all made of the same material. So this indicates that the resistivity will be same, or the amount of electrons per cubic meter, the amount of free electrons per cubic meter will be same. It also says that we have to rank in order from largest to smallest the resistances Ra to Re of these wires. So we know the resistance depends on two conditions, length and area. We can also say that resistance is directly proportional to the length. The greater the length, the greater the resistance. And again, resistance is inversely proportional to the area. So the greater the area, the less the resistance. So I'll be just using this formula. So for A, the value of Ra will be rho L by A. For B, the value of R will be, excuse my bad handwriting, the value of RB will be rho times L by, let's just substitute A with pi r squared. This will be pi 2r squared, which is 4 pi r squared. We can also write this as 1 by 4 Ra. For Rc, we can write rho times 2L divided by 4 pi r squared, or 1 by 2 rho L by pi r squared, which we can also write as 1 by 2 Ra. Now for Rd, we can write this as rho times 2L by pi r squared, or 2 Ra. Again, for Re, we can write it as rho times 4L divided by pi r squared or 2r squared, which is 4 pi r squared, which is equal to r a. So if you rank them from greatest to smallest, first comes rd, then comes re, which is equal to ra, then comes rc, and lastly rb. And just rank them like this. Alright, let me clear this out. So if you take a look at the second question, it says all the wires are all made of the same material. All wire segments are held at equal potential differences. Rank in order from largest to smallest the currents from IA to IE. So it says that the potential differences are equal. So delta V is equal for all cases or constant. So we know that I is equals to delta V by R. So as delta V is constant, we can write that I is proportional to 1 by R. So the greater the resistance, the less the current, which makes sense, I guess. So the series of current will be just opposite to this, which is ID is smaller than IE equal to IA, IC, and the largest being IB, which has the lowest resistance of all. Now let's move on to the next question, which states that a 2 mm diameter aluminum wire carries a current of 800 milliampere. The conductivity of the aluminum wire is 3.5 × 10⁷ per ohm per meter. So here we are given the conductivity, which is this, which we can also write as 1 by resistivity. So we have to find what the electric field strength, inside the wire. We have to also find the resistivity of the wire. We also have to find the resistance of 1 meter section of the same wire. So what is electric field? No, electric field is the field that is created by a source charge or something like that. To find the electric field, we can check what properties are given. So we know that electric field can be written as E equals to resistivity times electric current density, or we can write that electric field equals to 1 by conductivity times electric charge density, and the electric charge density being, which is J, being 1 by A. So we can ultimately write this as the electric field being 1 by conductivity times current divided by area of cross section. We can find this by using the conductivity mentioned here. We can use the current over here, but we have to convert it into ampere first. Then we can find the area using pi d square by 4 using the diameter over here. So I will not be solving this. You guys can solve it by yourself. And moving on to the next problem. What is the resistivity of the wire? So we know that resistivity is the inverse, multiplicative inverse of conductivity. So we can just use this and find the resistivity. Which will give us this ohm meter. And if we are asked to find the resistance of 1 meter section of the same wire, we can use R is equal to this value times L, which is 1, and area, which is this diameter squared by 4 times pi, which is 1 by this squared by 4 times rho ohm. Alright, this question asks us for the potential difference and drift speed of electrons. So it says that the free electron density in a copper wire is this much, which is Ne. The electric field in the wire is this much. So we are also given the value of E. What is the potential difference between 2 points in the wire that are separated by 20 centimeters? Alright, so it asks for the potential difference. We know that E is equals to potential difference by distance separating them. So we can find the potential difference as E times L, which also makes sense as E is volt per meter and length is meter. If we cancel this out, we'll get the potential difference. So delta V is equals to E times L, which is this. We have to convert it into meter first. And secondly, it asked for the drift speed or drift velocity. We can find it using the formula of I, where I equals to Ne times E times A times Vd. We have to keep Vd on one side and move it to the other side, and we'll find the value of Vd. We have the value of Ne. We know the value of E, which is minus 1.6 into the power minus 19. And for the value of A, we can use, we can just use the electric field to find the velocity. We don't need all that. We can just use the electric field. You know that drift velocity is directly proportional to the electric field. You can just use that. So if we move on to the next question, here it is said that a 15 centimeter long nichrome wire is connected across the terminals of a 1.5 volt battery. So the conductivity of the nichrome wire is 6.7 into 10 to the power 5 per ohm per meter. So you have to find the electric field inside the wire. So we know that E is equals to delta V by L. So we have delta V, we have L. You have to convert it into meter first and then find the electric field. What is the current density inside the wire? So we know that electric field equals to resistivity times electric current density. So current density equals to electric field times 1 by resistivity, which is electric field times conductivity. Conductivity is already given here. We can just use this value to find the electric current density. Now it says that if the current in the wire is 2 ampere, what is the wire's diameter? So we have E, we have J, we have I. Now we have to find the area, or we have to find the diameter, which we can find by the area. So we know that E equals to resistivity times J. E equals to, oh, we can just use the current density. We don't need to do all this. We can just use the current density that we found from here. We know current density J is equals to I by A. We can find A is equals to I by J. Now we can write A equals to pi d squared by 4, or we can write d squared equals to 4a by pi, or d equals to root over 4a by pi. So this will be the value of the diameter of the wire. We have to rank in order from largest to smallest the currents IA to ID through the 4 resistors. We know from Ohm's law that I equals to V by R. So IA will be 2 by 2 equals to 1 ampere. IB will be 1 by 2 equals to 0.5 ampere. Current C will be 2 by 1 equals to 2 ampere, and current D will be similarly 1 ampere. So if we have to rank it, we will write like IC is greater than IA equal to ID greater than IB. So that's all. Thank you for your patience, and bye bye.